Hello everyone and hello Professor Darren. In this video, I'm going to present about the definition of focus and directrix of conics. But before we start, let me introduce myself. My name is Wilbert and this is my first year as a mathematics student in Xiamen University, Malaysia. In the end of the video, I'm going to discuss about some general questions according to conic sections. Let's start from the first one, which is the history of conics. So, who discovered these conic sections? It was first found by an ancient Greek mathematician named Menaechmus around 360 until 350 BCE. Later, Apollonius of Perga wrote the definitive ancient word called conics. He detailed these properties of these curves and named them ellipse, parabola, and hyperbola. There is also another mathematician who studied about conics. In a sense, Menaechmus found them, but Apollonius systematically studied and named them, establishing the field of conic sections. First types of conic sections is an ellipse, which is an oval shape formed by slicing a cone with a plane at an angle. This ellipse is similar to the oval shape. The second one is a parabola. So a parabola is a U-shaped curve, and sometimes it can be an inverted U shape. It is formed by slicing a plane which is parallel to the side of the cone. Last but not least is hyperbola. A hyperbola is a U-shaped curve with two separate and mirror image branches formed as a conic section by a plane slicing through both halves of a double cone. Or we can say the plane slicing the cone vertically. And there is also a circle, which is the type of a conic sections, but it's just a special case. Now, let us move on to the eccentricity of conic sections. So, in a conic sections, there are two important components. First is the focus, and second is the directrix. We can let F as the focus, which is a fixed point on the plane, and L is the directrix, and it is a fixed line on the plane. Now, let's say this is the point of the focus, and this here is a fixed line, which is the directrix, or the line L. And let's say there's a point P right here. So we can say that the distance from the focus and the point P as PF. So this is PF. And we can define PL as the distance from the point to the line L of the directrix. This is PL. And yeah, that is the eccentricity, where the eccentricity is the ratio from PF to PL, or we can say the distance from the point P to the focus over the point P to the line, or the directrix. I'm sorry, this is PF right here. And this eccentricity represents the shape of the conics. Now, let's see the shape of the parabola in the xy plane. This parabola right here has a vertex of 0, 0. And we know that a focus is a fixed point on a plane. Let's say this is the point of the focus, which is P, 0, and a fixed line, which is the directrix right here. Let's say this is the line L, and the distance from the vertex to the focus is equals to P, which is the same of the distance from the vertex to the line, also P. Let one point P right here is equals to X, Y. So the distance is X, and this distance is equals to P. We know that the eccentricity is equals to PF over PL, which is 1. So first, let us find the distance from the point P to F. This is the distance of 2 points. So we can just use the formula x minus p squared plus y squared. And PL is equals to x plus p. Therefore, we can make it equal, which is PF equals to PL. x squared plus 2xp plus p squared. We can cancel out the x squared and the p squared. Therefore, the equation we got is y squared equals to 4px. And the focus is equals to p comma 0. And the directrix right here is x equals to minus p. X is an ellipse. So an ellipse contains two focus and directrix. And we can define the focus as f1 and f2, where directrix are the fixed line as L1 and L2. Let's say the distance from the center to the focus is equals to c. And we know that the major radius of the ellipse is equals to a. And we let one point right here is equals to p. So we know that we can find the distance from the point P to the focus is a minus C. Let one point right here is the D, and we are given the formula of the focus or the foci is equals to plus minus A times eccentricity, comma E. Because we let C be the distance from the center to the focus, therefore C equals to A times E. Or we can make it as E equals to C over A. Now, how are we going to find the coordinate of the line or the directrix? We know that the radius of the ellipse is equals to A, and we need to find PD. PF over PD. This is equals to the eccentricity. So we know that PF is A minus C, and PD is the one that we need to find. So we can change into PD equals to A minus C over E. Therefore, we know that the distance is A plus A minus C over E. So the directrices are A plus A minus C over E. From the eccentricity equation, we can get A equals to C over E. Then we change A into C over E plus A minus C over E. Therefore, we get A over E, comma 0. This is for the center in 0.0. But we must not forget that there are two focus and two directrix. Therefore, this become plus minus AE, comma 0. And there's also the vertices. Vertices, which is equals to plus minus A, comma 0. So the last type of the conic sections is a hyperbola. Let's say there's a point on F1, which is M, and F2, N. And we add another point, which is S and T on the vertex. And on the directrix, let's say there's a point Q. So suppose that the coordinate of F1 is equals to V, comma 0. And on F2, it is similar, but it is minus V, comma 0. Therefore, we can use the formula of eccentricity and we sum both of them. This is the first equation. This is the second equation. We know that the distance from the center to the vertex is A. Therefore, the distance from T to the center is equals to 2A. Therefore,
and the center
we
to
get
S.
MS plus NT equals to E QS plus TS. But we already know QS plus TS. How we find MS plus NT? We can find by using the distance of 2 points. And it is V minus V, which is equals to 2V. 2V equals to E times 2A. Therefore, V equals to AE, which is the focus. and it is similar to the equation of the ellipse AE, and the other is A minus E. Now we need to find the directrix, and this directrix is the same as the directrix of the ellipse. So when the x-axis line intersects the hyperbola, there is the vertices. And another thing is the asymptote. Therefore, we already found the focus, directrices, vertices, and the asymptotes of the hyperbola. But before we enter the last section, which is the general question, I made a mistake on the directrices. It should be, and also the same mistakes for the hyperbola. This should be x equals to plus minus a over e. And this is some of the general equation about the conic sections, which is parabola, ellipse, and the hyperbola. Due to time limitation, I will just solve this, and that is all of it. Thank you for watching, and thanks to Professor Darren who gave me this project, and hopefully it is useful, and I apologize if there is a mistake.